Well, hey, folks, how are you? Thanks for coming back and joining me on this episode of In The Loupe TV. Don Grandt, CTC, Cutting Tool Counselor, here to give you some information to make you more efficient at your spindle. Before we get started, you know the routine. Hit the subscribe, hit the like button. Subscribers are going up. I appreciate that. That means some of you like me, I hope. But that's great. Share it with anybody that you think might gain for the knowledge that we bring as a cutting tool company. What are we going to talk about on this one? We're going to talk about Weldon Flats. Side lock holders. Where do they go on? They have a Weldon Flat. Us as manufacturers put those Weldon Flats on the tool. Are they important? I like to think so. We have been manufacturing Weldon Flats for many years. But there is a purpose. There is a story. There is a way to use them. And there is a way to grind them. So stick around, come back, join us on this episode all about Weldon Flats. So hey folks, thanks for coming back. In The Loupe TV, short episode here. We're talking about Weldon Flats. First of all, what's a Weldon Flat? A Weldon Flat is a flat on the end of an end mill that locks into a holder like this. It's a side lock holder. It's a little bit more old school. It locks in there so when you get aggressive with your material, it doesn't slide out. Now, before we talk about Weldon Flats, let's just have a little bit of a history lesson because this is very important to understand. Weldon Flats have been around for many, many years, 50, 60, 70 years. I couldn't even tell you how long. It's an old school design, and it was designed for high-speed steel and cobalt. It's going to make a lot of sense. It was not designed for solid carbide, okay? Which means when we made Weldon Flats in the day, the industry standard was every place you put a Weldon Flat on a high-speed steel and cobalt end mill, that shank was to be differentially hard, which means the shank, or wherever the Weldon is not the same Rockwell as the cutting length and the diameter. It has to be softer. Now, why do you think it has to be softer? Well, when you look at a side lock holder and you lock down with a set screw, the reason we did that and the reason the industry standard is because of the high-speed steel is you want that set screw to bite into the material. And if it's 63, 64 Rockwell, which it is on the cutting edge, it doesn't bite into it. So the standard was that that shank had to be softer than the other end of it. It's going to start making sense because it wasn't designed for solid carbide. Even if you had a double-ended, believe it or not, if you had a double-ended end mill made of high-speed steel or cobalt, they would still anneal the center where the flat went in there to make sure it would bite. That's the history lesson. I want you to understand this because Weldon Flats were designed for high-speed steel and cobalt, not for carbide. Don't get upset. They work for carbide. We know that. But I want to explain how we need to evolve with the Weldon Flat and make it a little bit better for our application. Okay, so there's one other thing that's very important to understand before we talk about that Weldon Flat and putting it and using it for high performance cutting tools. You already know a Weldon Flat with high-speed steel and cobalt. So if you're using a high-speed steel and cobalt and it has a Weldon Flat, it's probably designed, the purpose, everything's fine. Don't worry about it. One other thing I want to point out with a Weldon Flat that's caused problems as we get into this, and we've corrected some of those problems. So, is Weldon Flats industry standard are measured from the back of the tool to the center of the Weldon Flat. Very important to understand. It's measured from the back of the tool to the center of the Weldon Flat. How does this cause a problem in the industry, and how did it cause a problem in the day? And this is still the industry standard that people are manufacturing Weldon Flats to. We've got a better mousetrap. I'm going to get there. So if your Weldon Flat is measured from the back of the tool to the center of the Weldon Flat, how does this cause a problem? Well, that distance from the end of your holder to the Weldon Flat is always the same. Okay? So if I take a tool with a 1-inch length of cut on a 4-inch blank and I put a Weldon Flat measured from the end of the tool and I put it up in that holder, I could possibly be hanging out of that holder with way too much extension than I actually need. Now, the opposite goes for that too as well. If I take that same 4-inch blank and I put a 2-inch length of cut on it, because the Weldon Flat is measured from the back of the tool, and I stick it up in there, Now my flutes could possibly be up into the holder. So the problem with measuring a Weldon flat from the end of the tool to the center of the Weldon flat is when you change your length of cut on the same inch blank, your length of cut and your extension varies from the end of the tool, and it's not consistent. And you can either have flutes up in the holder or you can have way too much extension out of the end of the tool. Understand that tool as we talk a little bit further about Weldon flats. So now let's talk about Weldon flats on solid carbide end mills, and how do we get smarter? How do we get more intelligent? How do we make a Weldon flat work the right way? Because the holders are similar. They're high performance now. So back in the day, they tolerances weren't as good. Now they're a lot more high performance. So if we're taking a carbide end mill and we're going to put a Weldon flat on it, I'm going to tell you what we're going to do. And I'm not speaking for anybody else in the industry, but I'm going to tell you what Helical Solutions is going to do on a Weldon flat. We reinvented that mousetrap, okay? First of all, what we do on our Weldon flats is we don't measure the Weldon flat from the end of the tool. We measure it from the top of the lift out of the flutes to the center of the Weldon flat. Now, why do we do this? Well, when you get a Helical Solutions Weldon flat, you're always going to have the maximum rigidity flute length from the bottom of the holder to the lift out on the tool. That's always going to be somewhere right around 100 thousandths. The key here is what Helical did was to try and maximize the old technology of a Weldon flat by measuring it from the lift out of the tool to the center of the flat. This way, you always get maximum rigidity and you never have those flutes up in the holder. That's number one with a Weldon flat. That makes us a little bit different, but you need to understand that when you're running standard Weldon flats that you might vary on that length coming out of there if it's not measured from the top of the lift out to the center of the Weldon flat. That's number one. So also now the fact that we're using solid carbide doesn't bite, right? I just gave you the history lesson in the beginning saying we want to bite down on that. Solid carbide doesn't bite. It's really hard, even harder than the hardest end of high-speed steel and cobalt. So what we want to do when you're using a side lock holder, and understand folks here, let's, come in a little bit closer. Let's talk about this. I'm not condoning putting a Weldon flat on an end mill. Side lock holders work very good, especially in the larger diameter stuff. It's fine to use a Weldon flat. A lot of the precision on the holders work really good. What I want to do is just explain a little bit better of how the Weldon flat works so you know when you want to use a side lock holder, and if you do, understand the features of that Weldon to make it a little bit better. So again, solid carbide doesn't bite. You can go back out. You don't give me some space now. It's fine. Solid carbide doesn't bite. So what we need to do is we need to put that tool up into the holder, solid carbide, bring in your set screw, and make sure you pull the tool down so it rests up against the set screw, and then tighten it. Try not to tighten in the center of the Weldon flat because that thing could slide inside of that holder because it's solid carbide. So you always want to be resting on that. That's one thing you want to take a look at when you're using solid carbide tools is make sure you're all the way up against it, because a solid carbide end mill, if it slips just a little bit, catastrophic. So you want to hold that thing right up there. You also want to make sure that the Weldon is parallel and straight. That's where we come in. We grind these, we grind them concentric, and we take care of everything to get that. So there's your tips. There's your tips on Weldon flats. Number one is, again, you want a Weldon flat to be measured from the lift out of the tool so you get maximum extension. That's what we do. We're proud of it, you know, and you'll see the benefits when you do that. Number two is make sure that you lock that Weldon up against the shoulder before you tighten that thing down, and make sure it's not in the middle or it's not at the bottom, because it will slide down. It's going to break your tool. It's going to be catastrophic for that. Okay, so that's it. Weldon flats, it's a short, but I'm going to leave you with one thing. I have to do this. I have to get this off my chest, because everybody always asks me, or I see in the industry of the old, I'm going to grind the Weldon flat on my bench grinder. So I have been doing this for so long, I don't get upset about grinding a Weldon flat on the side on a bench grinder. There's a lot of issues with that if you don't get it parallel, you don't get it straight, you don't put the 45 degrees on it and all that. My question, my biggest question, or my little story that I'd like to run through is, you go out, you spend the money on the equipment, the machine, you put the high pressure coolant on it, which is a huge add-on, probably $50,000. You get the right fixturing for that equipment, you buy the right holders, you get the side lock, and it's the Weldon Flat where you're trying to save the $8. I'm just saying. Put the investment in, you will see the benefits about getting a factory ground Weldon Flat, but if you do decide to grind the Weldon Flat at your facility, just try to make sure it's as straight, as parallel as possible. If you can put the 45 in it, that's great. You don't want any straight corners in there because it will get weaker and it will chip out. So I'm not condoning anybody by grinding your own Weldon Flats. I'm just saying that's where the rubber meets the road. And if you're going to use a Weldon Flat, it's always best to have the factory actually grind it on. Make sure they're using the correct specs. Well, hey, who knew Weldon Flats were so interesting? There's a lot more that goes into Weldon Flats. We're just trying to deliver the information. Hopefully you learned something from this. Hope you enjoyed it. Hit the subscribe, hit the like button. Please come back, share it with anybody you think gains from this knowledge. But before I go, 3 guarantees in life: death, taxes, and spring passes. Have a great rest of your week, folks.